Let's start with the bird's eye view of what I built. This is the complete architecture diagram. At the top left, you see the remote state backend. This is where Terraform stores the state file, a JSON record of everything we deployed. We use an S3 bucket called IAC-terraform-state-deanw- a really long number to store this state, with versioning and encryption enabled so we never lose history and state is always protected. Next to that is a DynamoDB table called IAC-terraform-locks. Its job is to prevent two people from running Terraform apply at the same time. If somebody's already applying changes, DynamoDB locks the state file, and the next person has to wait. In a team environment, this is non-negotiable. This bootstrap phase happens once, and then all future Terraform runs this backend. It's the foundation that makes Terraform safe and collaborative. Moving down, everything lives in the US-East-2 region. We choose this region deliberately in our variables, and everything scales to that region automatically. The main container is a VPC, Virtual Private Cloud, with a CIDR block of 10.20.0.0/16. That gives us 65,536 IP addresses to work with. All of our subnets and EC2 instances live within this private address space. Inside the VPC, we have two public subnets, one in each availability zone, 10.20.10.0/24 in US-East-2A and 10.20.20.0/24 in US-East-2B. These are public because instances here can directly reach the internet and the internet can reach them back. The way they reach the internet is through the Internet Gateway, this white box on the right. The IGW is AWS's door between the VPC and the public internet. It's attached to the VPC and has a route from both public subnets. When an instance in a public subnet sends traffic to an IP outside the VPC, the public route table says send it to the IGW, and the IGW forwards it to the internet. Responses come back the same way. Now we also have two private subnets, 10.20.30.0/24 and 10.20.40.0/24, also spread across both AZs. Instances in private subnets do not get public IPs by default. The internet cannot reach them directly, which is great for security. But they still need to reach the internet for software updates, downloading packages, etc. That's where the NAT Gateway comes in. It sits in one of the public subnets and has its own elastic IP, a static public IP from AWS. Private instances send outbound traffic to the NAT Gateway instead of the Internet Gateway. The NAT translates their private IPs into its public IP, so the internet sees traffic coming from the NAT. Responses come back to the NAT, which forwards them back to the originating private instance. This is one way. The internet can initiate connections to private instances, but they can reach out. Perfect for security. Behind the scenes, route tables control all this traffic direction. The public route table says any traffic going to 0.0.0.0/0 goes to the Internet Gateway. The private route table says the same thing except it routes to the NAT Gateway instead. Both public subnets use the public route table, and both private subnets use the private route table. This is why public instances can be reached from the internet while private instances cannot. In one of the public subnets, we deploy an EC2 instance running Amazon Linux 2023. It gets a public IP automatically. Protecting that instance is a security group, which is essentially a stateful firewall. It allows SSH port 22, only from your specific IP address, HTTP port 80 from anywhere, so anyone on the internet can visit the web page. All outbound traffic is allowed, so the instance can reach the internet for updates and external APIs. This is a classic security posture. Lock down inbound, except for what you specifically need, and allow outbound by default. When the EC2 instance first boots, it runs a user data script. The script is the key to reproducibility. It automatically installs Nginx, writes a custom HTML page saying hello from Terraform, enables Nginx to start on reboot, and starts the service immediately. No SSH, no manual configuration, just code that runs once and leaves the instance in the exact state you want. In real production, this might install monitoring agents, set up log shipping, or register the instance with a load balancer. So the whole architecture is remote state backend, VPC with 2 public and 2 private subnets, Internet Gateway for public access, NAT for private security, EC2 with security group and Nginx, all defined as code in Terraform. That's production grade infrastructure, secure, highly available, scalable, and reproducible. Let's dive into how we actually code this.